Okay, this is how to solve a quadratic equation. To be clear, a quadratic equation is an equation that has at least an x squared term in it, or some variable squared. It could also have a non-squared, but it has to have at least a squared term. And we went through 3 different methods for how to solve. The first one is completing the square. So that is a skill that you already saw how to use when you were converting from general to standard form. Here's how you can use it to solve a quadratic equation as well. So remember that when you're completing the square, you look at just the x squared and the x term. You take this coefficient of x after you have factored out the a term, which in this case a was 1, and you divide it by 2 and square it. So that completes the square. This part here with the blue term is a perfect square. I just need to subtract the 36 that I added to make sure that it remains equal. And I move that out. Again, if there had been a coefficient here other than 1, I'd have to take that into account and multiply by the negative 36. But in this case, it's just 1, so that doesn't change. And what I had done, this 36 that I added there, completes this square. This is now a perfect square. It'll always be written as x, and then half of this coefficient of x, in this case, minus 6, all squared. I combine these two terms here, negative 36 plus 20. That's where I got the negative 16. And now to solve, now that I've completed the square, I have a perfect square. And to solve that in an equation, I'll have to isolate the square and then square root both sides. So I would move this negative 16 to the other side, or add 16 to both sides, square root both sides. One thing that's crucially important is that when I square root, I have to take as my answer the plus and minus of whatever my square root is. Because the square root of 1 could be 1, it could also be negative 1. And finally, to isolate the x, I'll add 6 to both sides. That plus minus 1 means that there are 2 possibilities. Either I would do 6 minus 1 or 6 plus 1. The order doesn't really matter. I just did them to get the answers in numerical order. 6 minus 1 is 5, and 6 plus 1 is 7. Those are my 2 answers. And if I plugged either one back into this original, 5 squared minus 12 times 5 plus 20, that's equal to negative 15. And 7 squared minus 12 times 7 plus 20 is also equal to negative 15. Both of those work, and it's not a bad idea to check. So that's method 1. Method 2 is to solve by factoring. For this method, you have to have one side of your equation equal to 0. I will tend to use the side that has the positive x squared terms. And in this case, there's only one thing to move, so it's for sure easier to move things around in this fashion. Next, what I would do is factor this quadratic. Now, the thing with factoring is that it's not always factorable. It's possible that a quadratic equation will have an answer and that it won't be factorable, but in this case, it is factorable. This factors as x minus 5 and x minus 7, and if you multiplied it out, you get back the original. That works. And the reason that we factor is because factoring means writing as a product of factors. And if a product of 2 factors is equal to 0, then one of those factors has to be 0. So I'll look at those cases. Case 1, if this factor is equal to 0, means that x has to be 5. If I plugged in 5, this works out to be 0, kind of like the same theory that we used when we looked at restricted values in rational expressions. And for this factor to be equal to 0, x would have to equal 7. And just like it was in the previous example, those are the 2 answers. If I plug them both back in here, they would both work. And the final method for solving a quadratic equation is something called the quadratic formula. For the quadratic formula that I've abbreviated QF, you also have to have one side of the equation equal to 0. Again, I'll add 15 to both sides. And the quadratic formula is, it's a mouthful or a screenful here. It's a formula that you plug in the coefficients of x squared, x, and the constant. And this will work every time you have a quadratic equation. So 2 things to clarify. One is that the a, the b, and the c in this equation refer to the coefficient of the x squared term. In this case, a is 1. The coefficient of the x term is b. In this case, b is negative 12. and the constant is positive 35. So it's possible that you can not have any x term, which would actually mean that your b is 0. It's possible that you don't have a constant, which means that your c is 0. But this will always work. And this part in here, b squared minus 4ac, which has a special name, it's called the discriminant. This will tell you whether or not you have an answer at all. Because if b squared minus 4ac, that whole term over here inside the root, if that works out to be negative, you would have no answer because you can't take the square root of a negative. If this term in here works out to be 0, means that you only have one answer. And if it's any positive number, it means that you have two answers. In this case, when I plug everything in, remember that b was negative 12, a is 1, c is 35. The first thing I would do, order of operation wise, is simplify what's in the brackets here. And it also turns out that I can simplify this negative 12. So this 144 minus 140 is 4. When I take the square root of that, it's plus or minus 2. Plus minus is built into the formula. And just like we did with the first plus minus when we completed the square, this means that I'll have two answers. I'll have 12 minus 2, which is 10, divided by 2. That's 5, or 12 plus 2 divided by 2, that's 14 over 2, which is 7. And again, my two answers are x equals 5 and 7. If I plug them both in, they would both work, and that is it.